Hello. My name is Sabrina Alvarez, and I am a second year electrical engineering student. And today we're going to be presenting about how engineers build bridges, and I'm a part of Rensselaership. So, we're going to go through, here's like a little bit of an overview of what we're going to go through. So, first off, we're going to talk about what trusses and bridges are. Then we're going to learn about who helps create trusses and bridges, and then a little bit about the engineering process, and then we're going to learn about the different types of bridges, and then we're actually going to get to build our own bridge or do like a little simulation, look at some examples of bridges, mostly bridges that haven't been so successful, and then we'll leave the end for like questions, comments, or any concerns that you may have. So, a little bit about SHEP. So, what is SHEP? SHEP stands for the Society of Hispanic Professional Engineers. Our mission is to change lives by empowering the Hispanic community to realize its fullest potential and to impact the world through STEM awareness, access, and support and development. So, for SHEP, I am the treasurer. Been in SHEP for, I guess, after the semester ends, 2 years. And yeah, I think it's pretty cool. Um, Club, we had a GBM. We host like professional GBMs and social GBMs and um, just tons of events. And I definitely recommend showing up to a meeting. Okay. So, what are trusses and bridges? So, as you can see here on the right side, trusses are the triangular systems that are commonly used in the systems such as bridges. Oh, let me see. Okay. When a force is applied to like say right here at the corner of I like the top of the triangle, um, it results in either compression or a tension force. So if you like press down, that's compression, or if you um like not technically pull apart, but that would like a tension force. All right, and then bridges are like structures that provide passage over obstacles such as like water or like rough terrain or valleys. I've noticed, so I'm actually from California. I like can think of like two bridges at the top of my head from like the ones that you like see here on the page. But I actually visited the city recently, or like last semester, and I just noticed so many bridges, and I just thought it was really cool. Yeah, when building bridges, engineers need to consider like the location of the bridge, the type of design, because the location can affect the type of design of the bridge, and then like the material and the plans that they need to build a bridge. And this is so that we don't want bridges collapsing when like tons of cars go, or like for example, like in California where I'm from, like if there was an earthquake, we wouldn't want the bridge to collapse. All right, so talking about compression versus tension forces. A compression force usually happens when a force presses like inward onto an object, which causes it to become impacted or compressed. So here's my hand. I'm like giving it like a compression force, like I'm pushing it to the other side. And then a tension force is transmitted through cable, string, or a rope when it's pulled tight in opposite directions. So I don't have a string, unfortunately, but I do have my computer charging. So if I were to pull it, that'd be like a tension force. Okay, so then truss versus a bridge. So truss, it's like harder to build but easier to design and uses like less material because basically it's kind of like the structure of a bridge. And then trusses are like in a bridge. So like they're like I said, the structure of the bridge. And then like the bridge is like faster and easier and simpler to build because it's like once you know what you're trying to build, like easier to put it together. And then it also has like materials and like structures and everything to help have good support. All right, so who helps create trusses and bridges? So at the top of my head, um architecture engineers and civil engineers came to mind. So architecture engineers help build the structures of the physical bridge, and they're more like kind of like the design of the bridge, so make sure it looks, I guess, like a little bit aesthetically pleasing. And then civil engineers design the actual bridge. They like supervise construction and maintenance and ensure that um like physically it like works and holds all the like um force or like weight that's being on the bridge. All right, the engineering process. So all engineers have this in common, no matter what type of engineer you are, whether you're like a mechanical engineer, electrical engineer, civil engineer, environmental engineer. You're always gonna first try to ask, what is the problem that you're trying to solve? Um, because if you don't have a problem that you're trying to solve, there's really no point. And you have to see like what your focus is, what you're trying to do, and then you have to come up with like ideas, trying to imagine a solution. And then once you have that, you have to like plan, really plan out your solution, because you can't just right away go and start building something. You have to see like, oh, is this like ethically correct? Can we like actually do this like over a body of water? And then you should like create, so like usually engineers like design. So what we're going to do later, we're going to do like a simulation to like design, and hopefully we can test our bridges and see if like they would collapse if they were built in real life, or if they would hold like tons of weight when like trucks go through it. And then if you see that when you're creating something or when you're designing your solution, it doesn't work, obviously like this is the time to improve and do as many like um things that, or fix as many things that are needed, so that when you actually build your solution, it will work. And then so when you're doing that, there's a lot of testing and just making sure that it works. And then once you do that, you can go ahead and build it and share it with the world, and hopefully you're successful. And yeah. All right, so different types of bridges. So here we have an arc bridge here on the right side of the screen, a suspension bridge, a cable stayed bridge, truss bridge, beam bridge. Um, Usually at home, I usually see more of these, but I noticed in the city I saw like a lot of um, these as well. I think they're pretty cool. All right, building the bridges. So hopefully you're on your computer. So I will share the link again. Let's see, where is the chat? All right, share it again in the chat. It's not too hard to download, I don't think. So let me know if you've downloaded it and where you're at in the process, Preston, if you have decided to download the application.
Oh, I got it.
You got it?
I'm pretty sure it's like loading up now.
Okay. Let me know when you get to this part. I'm also gonna stop the recording.
Yeah, I got it.
Okay. I'm gonna pause it. Okay, I forgot to continue recording. But basically like, and this let me see, 1 2 3, 1 2 3. All right, let's do the test. So load test. this. Oh, it's a little crazy. Ooh. Um, yeah. Mm, oops, no. Oh, what is this way? Down. This way. Down. Be cool looking bridge. No, it's still this. Let's see. Hmm. Not. It's not letting me go. Me. Pause the recording. So here at the top left, you see how it says like file, edit, view, tools, test, report, help.
Oh yeah.
Yeah, test, and then you do the load test or like show animation. We'll do load test. Oh, why isn't it going? Hmm.
Oh,
Well, it was working before, but you basically go here and then do the load test. Let me see if I can get
gotcha.
it to work again. Okay, so this is what it looks like once you press test and load test, and then it'll like create actually put your like trusses together or like your design together, and it has a truck going through it, and then see how it bends a little bit though, so that's not good, but yeah. All right, have you gotten your bridge to work, Preston?
Oh, not yet. I kind of started over. I thought about something else I could do, maybe like a cross
Okay,
section.
okay, that sounds good.
I wonder how much it's gonna cost though.
Second. So I won't go through like, well, this is like the last slide I wanted to show since you went through it all pretty quickly. But in case for the recording, basically you're just after you download this, you're gonna want to continue next, and then I agree. Then
Yeah,
you're gonna have to ensure that both the bridge designer and the register file extension are selected, and then you're gonna press next, and then up to you if you want to install for anyone using this computer or just for yourself. I think it's fine for anyone using this like the computer, but it's totally up to your decision. Press next, and then you are gonna go ahead and see where you would like to press or put in the your like the app that we downloaded. So you just select where you want it to go. You can browse and see if you want to select a specific folder, and then you press next. And then this is fine. You don't need to create any shortcuts. You can just go ahead and press install. It should install. Ensure that Run the Bridge Designer 2016, the second edition, is checked off, and then you'll press finish. And then you can go ahead and start designing your bridge. But since we're almost out of time, I just wanted to share like a last few words. Basically, like when engineers are like designing their bridges or their trusses, they always want to see that their desired load is something that, or not the desired load, but the load that goes on the bridge, that the bridge can abstain the load. Because sometimes, I don't know, when like there's bad weather or something, or earthquakes can always cause like structures to, it goes like shakes really bad and then
yeah,
causes bridges to collapse. So, engineers always have to ensure that they that the bridge that they build can abstain the load and anything else, any like outside factors like an earthquake. And then also obviously there's always like money involved in like anything, so cost is really important for them as well. They can't go like over the budget, so they have to ensure that not only are they using like good material, but material that would be within their budget. So that's three different things that engineers have to think about when designing their bridges. Um, so before we end this, I did want to do an example of the San Francisco Bridge. So it collapsed a little more than 30 years ago. The Bay Area. I'm actually from LA, so this is pretty far from where I'm at. But as you can see here, um, if engineers don't do their jobs correctly, it can not only cost more because they have to like build everything all over again and all the damage that they've made, but they also do affect a lot of lives.
yeah,
Bridges can like kill people. I know there's like, people on the bridge and it just collapsed. Souls are lost. So that's not good. See here, we can see paramedics taking people away after this bridge collapsed. And it was because there was an earthquake as well. As you can see here, so this was like a truss bridge and it just like went like this in the middle.
yeah.
So I know you're a mechanical engineer, so you'll probably take PD2 soon-ish. In that class, we basically talk about like basically like all the wrongings that engineers do, like stuff that happens and why it happens. So this could be like one of the things that maybe discussed. I know like recently we talked about it wasn't exactly a bridge, but it was like a hotel, and one of their like walkways did collapse. Um, so I like kind of thought of it. It's like kind of like a bridge, you know, connects one place from another place together. And
Yeah.
it collapsed and it like just caused like the lives of so many people to like end. So I really think it's important. And I really
Did it
think
collapse midway? Oh, I'm sorry.
wait, what was that?
Did it collapse midway? Like at the center point?
This bridge?
Yeah.
Yeah. Oh, actually not the middle, but like it looks like where it's like it probably looks like one of the sides. Like as you can see here, like there's like the like bottom part and then like the top part starts here. So I'm saying like right when once you get onto the bridge, I think that's where it collapsed. It's really
Yeah.
unfortunate, especially because it looks like there's water too. So all the cars that were crushed. Yeah, it caused a lot of damage. I don't know why there's someone in a lamp. So yeah, but this overall like is like going back to like the engineering process, how you know you have to design, um, go through like designing and then testing, a lot of testing because then stuff like this can happen. So
Yeah.
we're almost out of time. We have like 3 minutes left. Not sure if you want to share. I'm gonna stop the recording now. Basically it was like just time for you to build your bridge, but I'm gonna stop it.